So let us quickly have a look at the surface currents in the American Mediterranean Sea as derived from satellite-tracked GPS drifters. Okay, so you chuck drifters floats into the ocean and you work out the pathways, just from connecting dot by dot connections of the location. And this is what's shown here. These spaghetti plots show you the Caribbean current, okay, which is a relatively broad current system running through the Caribbean Sea into the Gulf of Mexico, where it forms a loop current, the loop current. Okay, and the loop current runs around in the Gulf of Mexico as one narrow path, one narrow loop, and there is a region which is a more sluggish, excluded from that, okay, which is in the inner part of the Gulf of Mexico. You have a secondary circulation. So if you're unlucky and you end up on a pathway that leads you into the interior of the Gulf of Mexico, where you might have to spend a much longer time in this area. Okay, so if you plan a trip with your grandma into the Gulf of Mexico, taking advantage of these currents, and you go into the Caribbean current, you drift along here, it might happen that this current throws you into the interior of the Gulf of Mexico, where you're sort of isolated from the strong boundary current of the Gulf Stream. Okay, so this is now indeed linked the Gulf of Mexico to the Deepwater Horizon oil spill in 2010. There are some photos here. And indeed, for a system like the Gulf of Mexico, it strongly depends, the consequences that you have from an oil spill strongly depends on where you have that oil. Whether you have it in the interior of the Gulf of Mexico here, or whether you have it more closer to these strong boundary currents. Because the boundary current itself actually will disperse oil spills much more rapidly than the more excluded regions in the inner Gulf of Mexico. Okay, that was just a note.